This is problem 12 on the second midterm, and it reads, a specially prepared semiconductor has a free electron density of 1 times 10 to the 27th electrons per meter cubed, and free holes, a mobile entity with charge positive E, with density of 3 times 10 to the 27th holes per meter cubed. It is observed that the drift velocity of the electrons is to the left. Which of the following must be true? E is the electric field, I is the total current, JH is the current density of the holes, and JE is the current density of the electrons. So the first thing we can figure out is I, which is current. We want the current I to point in the same direction as the motion of positively charged particles. That's the definition of current. The free holes have positive charge and move in the opposite direction of the electrons. So the holes move to the right because the electrons move to the left, meaning that I is to the right. The next thing we can figure out is current density, or J. Current density points in this direction of the drift velocity of the particles, unless the particles have negative charge, in which case it will point in the opposite direction. The electrons move to the left, which is given in the problem, so JE is to the right, and the holes move to the right because they move in the opposite direction of the electrons, so JH is to the right. Lastly, we need to figure out electric field. Current density points in the same direction as electric field, as can be seen by this formula, J equals E over resistivity. Now resistivity is just a scalar, so it doesn't change any direction, and J and E are both vectors, which means they have direction. Since J is to the right, E is to the right as well. That means the answer is B. I, E, JH, and JE are all to the right.